All right, last time we were taking a look at section 14.2, and we had gotten to the point where I believe we had written down Fleury's algorithm. Does that sound right? All right, so let me make mention of what I was talking about when I overemphasized something. We were talking about Euler circuits, and my mind was thinking about Euler paths, and I talked about the fact that odd degrees are sort of omitted from the description in here. We're going to see something happen with Euler paths that reference the odd degrees, which was where my mind was going when we were talking about this. So on this particular one, when we're talking about Euler's theorem, talking about circuits specifically, even degrees means we have circuits for all of our points, and non-even or any odd degrees means we won't have a circuit. However, there are places in which case we would have an Euler path, which we'll talk about in a moment. Okay, so you had written down this algorithm. Let's just run back through it before we get started on looking at it. This is one of those places where it sounds harder to do when you write it down than it really is when you do it. The basic idea is that you're going to start at a vertex. If it tells you where to start, you start there. Otherwise, you can start at any vertex. And you're going to go along any edge connected to that vertex. So as you begin, you have choice in how to do that. You start having choices eliminated as you go because you're not going to be repeating any of the edges, and you want to make sure that as you're making your choices as you go along these different edges that you're not doing certain things. For example, it says that we are going to make sure that we don't cross and remove any cut edge. All right, so we want to make sure that we're not breaking the graph apart in such a way that we can't achieve the goal of getting to all the points. So if we have a choice to make, and one of the choices would lead us back and finish a circuit that means I can't finish something afterwards, then I can't go there. So there are some limitations, but I do have a lot of flexibility as well. So I'm trying to go through each one of these edges, not cutting anything apart until I've completed an Euler circuit. That's my goal. And this is the one that we're going to do. And as we do this, if you were to look at the material in my math lab or in the textbook that's associated with my math lab, I'm going to model what they're doing there, which is to sort of highlight or scribble out the edges that I've accomplished as I've accomplished them. This one actually tells us where to start. So we need to make sure we start where it says. We'll start at point A. So this is our starting point. And as we do this, while we do have lots of flexibility, we're all going to do it the same. Otherwise, we're going to get things really confusing.
Our graph looks different.
Your graph looks different than that. And what's it look like?
H connects to F instead of G.
H connects to F instead of G.
Yeah.
Okay. So I think yours is just missing a particular segment. Is that true?
No, there's no segment between H and
Oh, wonderful.
Yeah.
Okay.
It makes like a star.
All right. Typo on the piece of paper. First one of the day. So sorry. Go ahead and adjust it to look like this. This is what my notes, let me see. Let me make sure what I have. This is what happens when you have to make the pictures multiple times. The one that's on the screen is the one that I want, plus an additional line segment that is missing, which should be right here. That's the graph I want. Okay, so can you make adjustments to what you have? So go ahead and connect B to F. And then
G to.
you need to, it's not even labeled on your paper, the H, is it? Okay, label the H on the left-hand side. See what other fixes we have. And then we do not have the HF line segment, but we have one from H to G and G to F. I'm so sorry. Use some kind of something to scribble out that you are not going to use the segment that says HF.
And will we also not use the B to D?
The which one?
B to D.
That should be there. That's missing from my screen. I apologize. We'll fix that. Yep, that should be there. Okay. Does your graph match mine now? If you've made those fixes, I'm so sorry. Okay. And also, oops, that's not what I want. Get the image down here and copied. So we're definitely going to make a mess of this picture. Okay. Let's try again. So we're starting at point A. Are we good-ish now? Lovely. Okay, we get to pick where we go next, which means probably whatever I've got on my paper is probably not what you're going to pick, so I'm not going to look at it. We're going to try to do it together, all fresh and so forth. A has lots of places it can go, right? It's probably worth noting that we need to check and make sure that we have even degree everywhere. I believe that we do, but let's just double check. We'll go in order. A has degree what?
3,
4. B? 6. 6. It's okay. C? 2. D? 4. E?
2,
F?
4,
G?
4,
H?
2,
Is that it? J? Sorry, J. I skipped I. 2. And K?
2.
2. Okay. So they're all even degree. That tells us an Euler circuit is going to exist, correct? Great. And it tells us in the directions we're starting at point A, so we will make sure we start at point A. All right. We get to pick. Where would you like to go after you go to point A, or start at point A? Okay, so we go from A to G. And as we do that, I'm going to scribble along the edge. We just need to make sure that we're not cutting things apart in such a way that it disconnects the graph. Eventually, we'll disconnect the individual locations, like the points of the graph, but I don't want to disconnect anything I haven't achieved yet, like any of the points I haven't been to and so forth, okay? There's some places where that might happen, and it also might not happen depending on how we pick things. After we go to G, where shall we go?
H.
H. Okay, so we've got G to H. All right, we do not have a choice now because H only has one other point or edge attached, right? So H is going to go back to A. And that's totally fine because I can still, continue from point A, right? So after A, now I need to pick another point. I've got 3 options still. 2 options still, sorry, 2. F, okay, we can go down to F. Okay, so I need to be a little bit careful making sure things happen and don't happen this way. So F has 3 different edges that we can go to next, but all 3 of them still allow me to get either back to F, right? So if I decide to go from F to GA or F to G, I can still get back to F and move out. So that's okay. If that weren't the case, I'd need to be careful that I didn't go there next. Same thing if I go from F to B, that doesn't disconnect the graph either because there's still a line segment, or an edge, connecting the A and the B. So I still get to have flexibility. Which one would you like to go to next? J. Okay, so we'll go to J. By doing so, I've forced myself then to go to G and then to F. So notice I'm repeating the segment, or the vertices, but that's okay. That's not allowed. After that, I don't have another option either. F only has one edge left, so I'm going to go up to B. So where would you like to go from B? Got lots of choices. You can't go back to A. That's the only thing you can't do right here. Why can I not go back to A right now? I would disconnect it and I would never have achieved the goal of getting to the other side of the graph. So I can't go back to A. But I can go to C, to D, or to E, or to K. Lots of choices, just not A. Which one do you want to go to? Yes.
We have an extra line for H to F.
Yeah, I scribbled that one out, but I probably didn't say that loud enough maybe. So yeah, there's a line on your graph that shouldn't be there, and it is the line from H to F. So eliminate that line. That should not be there. Sorry. Thank you. All right. B, where do you want to go? E. All right, so if we go to E, then I have to go to D next. So I'm going to do ED. Okay, where am I going to go after D? I have choices again. Okay. Okay, so if I go to K, then I have to go to B. So K and then B. C. Okay, so if I do C, then I have to do D. And I'm stuck at this point because there's only one way out of D. I would go from D back to B and then over to A. Okay, so the process itself on this one especially had very limited places where I was like trapped. I can only do this now, right? I mean, there's only a couple places where it's like, well, I can't do that. I can't do that. Most of the places I either had flexibility or I was necessarily going to follow another path because that's the only way out of there kind of thing. But there's lots of different ways that we could have constructed this, starting from the fact that we initially decided to go from A to G. We didn't have to do that, right? There's other things that we could have done. Euler path note. So this is actually what I was referencing before we started today. If we don't have all even degrees, while we won't have a circuit, we do still have the ability potentially to have an Euler path. That would happen if we have exactly two vertices of odd degree. Okay? So if that happens, we would actually start at one of those vertices of odd degree, and then we would end at the other one. Start at one vertex, end at the other one. But we would still have the ability to create an Euler something. It's just not an Euler circuit. It'd be an Euler path. Clearly we should try one, right? Obviously that's where we're headed. And let's see if my picture looks like it's supposed to this time. So, just a second more writing. Okay, analyze the picture starting with. All the pieces where they're supposed to be. All my dots are missing. That's excellent. Let's put those in. Is there an A to C missing? Oh yeah, for sure. Okay, are all the pieces okay? Yeah. Okay. Let's fix this one at the bottom too. All right, so I'd like for you to start by going through, we'll do it together here in just a second, but go through and put the degree next to each of the vertices. Just write it down. Okay, I wrote mine in yellow. Do they match yours? Looks okay? All right, so why will this not have an Euler circuit? They're not all even. Why will this have an Euler path? There's exactly two that are odd. Okay, if I had 3 that were odd or 4 that were odd, that would be a no-go. But I just have the 2. What that also tells me is that I have to start and end at one of those odd vertices. So I do have a choice, unless it tells me in the directions. I don't think it did. It didn't. So I get to pick. Do you want to start at B or C? C? All right, we will start at C. So starting at C, we have complete freedom once again at where we go next. We can even go to the other odd vertex if we want to at this point. But it's your choice. Do you want to go to A, E, or B? It's okay. We'll go to E. I heard both of them at the same time. We'll go to E. All right, so if we go C to E, then where would we go? We've got lots of choices out of E. F. Once I choose F, I'm going to go all the way around that triangle. So F, G, and then back to E. Okay, so I'm back at E now. D, okay. And there's only one in and out of D, so D puts me automatically over to A. E, okay. And I think there's only one exit out of E at this point, which puts me back over to B, right? E to B. And then what? B to A. And then A to C and C to B. All right, so once again, we didn't have any places along the way where we had to say, well, I can't do this, or I would end up heading back to the starting point like we did in the last one. But again, had we chosen a different arrangement of letters, there would have been places where that happened. In fact, the arrangement that I did when I originally did it, and it's in my notes, had that problem happen, where there was a place where I was like, oh, look, I can't do this, or I would end the circuit, or not the circuit, but it would end the ability to get out of a particular point. So just be aware as you're going is that sometimes you're going to run into places where you don't have choices because that choice would end the ability to get to any other point, right? So if we had gone in and out of E enough times where we used all of this and then we came over here and we had no way to get back out of E, that would have been a case where that would have happened. So there are cases where that's the case. All right, any questions? Okay.